Evening to everyone. Welcome back to another lecture on Resultant JE YouTube channel. I'm Vikas Sir. I welcome you all to this session on fluid mechanics practice session, where I'm going to discuss important questions on fluid mechanics. Just a second. I think the PPT here is not correct. Just a second. Oh, just a second. Yeah, everyone please quickly join me for this session. In the meanwhile time, let me just correct this thumbnail. Yeah, good evening everyone. Good evening. Please everyone quickly join me for this session. Good evening all of you. Welcome to this session. Good evening everyone. Good evening. Welcome to this session. I hope all of you are doing fine and you are ready and excited to practice some important questions on fluid mechanics subject with us. So as you know that normally I don't take classes on Saturday and Sunday, but today is a special session. Actually, this session was supposed to take place yesterday, but yesterday I was not feeling good. I was not feeling good yesterday, so that's why the class was rescheduled for today. And today also I have changed the timing to 8:15 for some reason, because there was some family, some birthday celebration going on, and so on a video call, so I was not able to attend the session at 8 p.m. So that's why I have changed the timing to 8:15 p.m. Okay. Hello Geet, MS, good evening, welcome to the session. Now this session is important for everyone who wants to basically prepare for SSC JE and RRB JE 2024 exam. And I'm here with important questions on fluid mechanics. आपका IOCL का पेपर था, कैसा गया? How was your paper, राम अचल? कैसा गया आपका पेपर? Good evening everyone, good evening. Just give me a thumbs up if my audio and video is fine. Not that thumbs up, I don't want to drink thumbs up, but I'm saying that just tell me in the comment box if my audio and video is fine. And those who have joined me for this session, if you have not subscribed to our channel, then please do it and also press the bell icon. Okay, and also do not forget to like and share the session. This is my short introduction about myself. I am Vikas Sir, Faculty of Mechanical Engineering, who will be teaching you these important subjects of mechanical engineering today only for fluid mechanics subject. And this is my email ID, this is my Telegram, and that's all about me. Hello Neeraj, good evening, welcome to the session. I will not be wasting much time of yours. Let's quickly jump to the paper, and this is the first question on the screen. Question number 1. Today I have more numerical question. I have got more numerical question for today's session. So don't run away from the session thinking that sir is going to only provide numerical questions. Okay, so let's solve this question. They are all important questions of fluid mechanics. First question: a spherical water drop of 1 mm in diameter splits up in air into 64 small drops of equal size. The surface tension coefficient of the water in the air is 0.073 Newton per meter. The work required in splitting up the drop is? Yes, tell me the answer for this question. How are we going to solve this question? Yes, that's a very simple question. And here you have to utilize the concept of surface energy per unit area. So which work will be utilized in splitting it? Yes, this water droplet will be splitted because of which thing? So water droplet is having the diameter. So we are having a big droplet of the water. Okay. and it splits into 64. It splits into small droplets, small 64 droplets. I am not going to make 64 droplets. Just think about it. This is the splitting of a large droplet into small droplets. Okay. Now the diameter of this droplet is given. Big droplet is equal to, the diameter is 1 mm here. Okay. So if the diameter is 1 mm, you can simply say the radius will be 0.5 mm. The radius will be equal to 0.5 mm in this case. Now, how many droplets? Number of droplets here, number of droplets in which it splits is equal to 64. Let's take this as n. N is equal to 64. Okay. Now, one thing that we are going to apply in this case is, let me just take a blank slide here. The volume of the droplets, droplet before splitting, whatever is the volume of the droplet, that will be equal to volume of the droplets after splitting, because volume will remain same now. Okay, no matter that big droplet is basically breaking into 64 small droplets, the volume of the big droplet will be, it is a spherical shape. It is, since it's of spherical shape, the volume will be 4/3 pi r cube. And what will be the volume of this small droplet, 64 small droplets? The volume of 64 small droplets will be, it will be n into 4/3 pi r cube, where let us say r is the radius of small droplets in which the big droplet has splitted. Okay, clear? Now from here you know value of n, you know r, so just this will get cancelled out. Okay, this will get cancelled out. From here you will get the value of r. Okay, you will get the value of small r. What will be the value of small r? Small r will be equal to 0.125 mm. Okay, this is the radius of small droplets. Okay, now you know the concept of surface tension, that surface tension is equal to surface energy per unit area. That is also one formula for surface tension. Okay, so surface energy before splitting will be, before splitting of the droplet, surface energy will be, it will be surface tension into area. Into area will be 4 pi r square. Surface energy after splitting will be, surface energy after splitting of the droplet will be, that will be n into sigma into 4 pi small r square, right? So the work required in splitting of the droplet, what is the work that will be required? That will be equal to, it will be, let us say this energy is E2 and this energy is E1. Okay, so that will be E2 minus E1. Okay, so simply if you solve it, you will get 4 pi into sigma n into r square minus r square. Just put all the values, you will get the answer. So when you solve it, you will get 0.687 into 10 ki power minus 6 joule. This will be the total surface energy required for splitting, 0.69 10 power minus 6 joule. So I hope all of you understood the question. Is it clear, everyone? So that's the first question for today's session. The work required in splitting the drop is nothing but surface energy after splitting, surface energy after splitting, surface energy before splitting. In just difference of these two, you will give you the value of the work required in splitting. And when you solve it by putting all the value, N is equal to 64, R is 0.125, capital R is 0.5, okay, and sigma, that is surface tension, is given as 0.073. Put all the values, you will get the answer. Clear? Next question. If a pipe contains an oil of a specific gravity 0.9 and a differential manometer connected at the 2 points A and B, show the difference in the mercury. I think this question is a little bit incomplete. I think I don't know how this question is incomplete. Let me just search it. Yeah, just give me 1 second. Huh? This question is little bit incomplete. Yeah, this is a question. A flat plate 0.1 meter square area is pulled at 30 centimeter per second related to another plate located at a distance of 0.01 centimeter from it. So we are having two plates, okay. The plate area is given in the question is 0.1 meter square, okay, is pulled at 30 centimeter per second related to another plate located at a distance of, the distance between these two plates is 0.01 centimeter, and let's say the upper plate is moving at a velocity of 30 centimeter per second related to the lower plate, okay, and between these two plates, the fluid is having water with viscosity of 0.001 Newton second per meter square. The power required to maintain the velocity will be, how to find the power? The power will be equal to force into velocity, okay. Force, how you will find the force? Force will be equal to mu into A du by dy into velocity, okay. So in this question, mu is already given, power will be equal to mu is 0.001, area is 0.1 into du is 0.3, dy is 0.01 10 power minus 2 into v, velocity is 0.3. Solve it, you will get the value of answer. The value of power will be 0.09 watt. I know that you have already seen this kind of question, but because I am basically selecting the best questions from fluid mechanics, so this is also one of the good question, okay, where you don't have to find the shear force, you have to find the power. Power is equal to shear force into velocity. And how you get shear force? Shear stress is equal to mu du by dy according to Newton's law of viscosity, and tau is the shear stress, which is equal to shear force per unit area, which is mu du by dy. So from here you will get the value of shear force as mu into A du by dy, and multiply this force with velocity, you will get the power. Clear? Simple. Next concept is the concept of manometer. If a pipe contains an oil of a specific gravity 0.9 and a differential manometer connected at the 2 points A and B of the pipe shows a difference in the mercury level as 15 centimeter, the difference of the pressure at the 2 points is, you know why we use a differential manometer? Differential manometer is used to find the difference of the pressure between 2 points, okay. Let's say we are having two pipes, and if you have to find the difference of the pressure at two different points in the pipe, then you use a differential manometer for that purpose, okay. It will find the difference of the pressure between at 2 points. So let's say these are the two pipes. This is pipe number 1 and this is pipe number 2. This is a manometer, and that manometer is basically pipe contains oil whose specific gravity is 0.9, and obviously manometer manometer contains fluid which is mercury whose specific gravity is 13.6 because it contains mercury. Okay. The difference of the pressure when this manometer was used between two sections of pipe, the difference of the pressure was 15 centimeter. Okay. So X is equal to 15 centimeter. That is the differential, that is the deflection of the pressure, 15 centimeter. So how you find the difference of the pressure between 2 points? First of all, you need to find the pressure head. Pressure head will be equal to X, specific gravity of the mercury divided by specific gravity in the pipe, minus 1. From here you will get the value of pressure head, which is 0.15, 13.6 by 0.9 minus 1. After that, you know how you will find the pressure. Pressure is equal to rho GH. Okay, just multiply with. Now you will be thinking, sir, which rho will be taken for here to find the pressure? Obviously, the pressure of the density of the oil. You have to take density of the oil, which will be 900 into 9.81 into H. This H has to be kept here. Clear? Clear? So just solve it, everyone. Tell me the answer. So you will get, if you solve it, you will get pressure as 18688 Newton per meter square. That is option C. Clear? You don't have to find the pressure head in this question. You have to find the pressure. And there is a big question or big confusion. Sir, which density we have to keep in the formula of pressure? Right here we have two density. One is density of the fluid in the manometer, right? And one is density of the fluid in the pipe. Because you have to find the difference of the pressure at the 2 points of the pipe, so you have to use density of the fluid in the pipe, right, which is 0.9. Specific gravity is 0.9, so density will be 900. So you have to use this density in order to find the pressure between 2 points. Clear? Is it clear why we have used 900 as a density? Why not 13600? Clear? Next question. It is required to find pressure difference between two horizontal pipes through which water is flowing using inverted manometer. Two manometric fluids with specific gravity 13.6 and 0.8 are available. Okay. Which manometric fluid is to be used now? Because in this question they are using inverted manometer. And if you have read, I hope you have studied somewhere that inverted manometer, whenever we use inverted manometer is used to measure pressure difference of underground pipeline, like the pipelines are there underground and the pressure difference is low. You have to measure low pressure difference. In this situation, we always select which manometric fluid should be used. So in that case, the fluid in the manometer, fluid in inverted manometer should be of low specific gravity. So this is very important concept. Okay, whenever we'll be using a inverted manometer, then we'll make sure that in the manometer we use a fluid which is having low specific gravity. When we use a normal manometer, then we use a fluid which is having high specific gravity. Okay, a vertical rectangular plane surface is submerged in water such that its top and the bottom surface are 1.5 meter and 6 meter below the free surface. So we are having a vertical and rectangular plane surface, and it is below the free surface. So let's say this is the free surface of the water, and the top surface of this rectangular portion is 1.5 meter below the free surface, and the bottom portion is 6 meter below the free surface. Okay, this is the question. You have to find in this question the position of center of pressure is below the free surface. That is obvious, center of pressure will lie below the free surface. You have to find the position of center of pressure. What will be the position of center of pressure? Now, center of pressure position you have to find. You know what is center of pressure? It is denoted by H. Center of pressure is Ig sine square theta over A H bar plus H bar. This is the formula. You must have studied this formula. And because it is a vertical rectangular plane surface, so theta will be equal to 90 degree because it is vertical surface. So center of pressure position will be Ig, which is moment of inertia, divided by A H bar. H bar is the centroid plus H bar. Now question is how to find the centroid. Where will be the centroid, my dear? The centroid will be exactly at the center of this vertical plane surface. This distance will be 3 meter and this distance will be 3 meter. A total centroidal position will be H bar will be, so H bar will be 1.5 plus 6 by 2, which will be 4.5 meter. So position of centroid will be this. Clear? Is it clear to everyone? This will be the position of centroid. Now, what will be the area? Yes. Next question is how you will find the area and moment of inertia. Tell me. How you will find the area and moment of inertia in this case. Try to solve this question, everyone. And if you are not able to solve it, obviously I will tell you the answer. So you will find that I have taken question from all the topics of fluid mechanics, from complete fluid mechanics and machinery. Okay. So here in this case, we have to take an assumption. We have to assume that width of the rectangular plate is 1 meter. We have to assume that. Okay. So width is 1 meter, and so from the free surface, you have to find the position from the free surface. From free surface, area will be 1 into 4.5. That is 4.5 meter square will be the area. And moment of inertia will be equal to 1 into 4.5 meter cube by 12. Okay. This is how you will find the moment of inertia. Okay. So just put all the values in the question and you will get the answer. This will be 4.5 cube by 12 into 4.5 into 4.5 plus 4.5. When you solve it, you will get the position of center of pressure from here. That will be 4.2 meter. Are you all getting 4.2 as the answer? Tell me. H bar is 3.75. 3.75. How are you all finding 3.75 as the H bar? Oh, sorry. Yeah. That's a mistake. H bar will be sorry. This will be 3.75. H bar will be 3.75. So this will be 1.5 plus 6. This total height is from here to here, it is 6. Okay. But you have to find this half of this. So this will be 6 minus 1.5, which is this distance, divided by 2. So you will get 3.75 meter. Sorry. Yeah. My mistake. This will be 3.75. Okay. 4.5 into 3.75. you will get 4.2 meter, but I think the mistake was I have taken it as 4.5, but this will be, see, this distance we have to subtract in order to get the value of basically 1.5 is the distance from this from the top surface, and what will be the total distance, because from this point to this point the total is 6 meter. Okay, so we have to get this value. This value will be, what will be this value? This will be 6 minus 1.5 divided by 2. Okay, so if you add it, you will get the total centroid position. Clear? Is it clear to everyone? Next question. A metal piece having density exactly equal to density of the fluid is placed in the liquid. The metal piece will. A metal piece having density exactly equal to density of the fluid. So because we have fluid, and in that fluid we are keeping a metal piece whose density is exactly equal to density of the fluid. So if the density of this metal is exactly equal to density of the fluid, in this case what you will find, that this whole metal piece will be wholly immersed. It will wholly immerse in this case. Yeah, right answer is option D. There are two other cases. Sink to the bottom is a case when density of this metal becomes more than density of the fluid. And these two cases, partially and float on the surface, this happens when density of that metal is less than density of the fluid. So these three cases, all the three results will come depending on the difference of the density between the two. If the density of the metal is greater than density of the fluid, then this metal will sink to the bottom of this basically fluid. And if when it will float or partially immerse, when the density of the metal is less than density of the fluid, when the density will be equal, it will wholly immersed. Consider the following statement pertaining to stability of floating bodies. A floating body will be stable when the center of gravity is above center of buoyancy. The position of the meta center corresponding to different axes of rotation are generally different for the same floating object. Meta center position are different for different floating object. For cargo ships, metacentric height varies with loading. Center of gravity is above center of buoyancy. Floating body, the position of the or stability condition of the floating body, is it determined by the center of gravity and center of buoyancy? Are these two important, plays important role? No. They will not play important role here for the stability. Stability of floating body is determined by meta center or metacentric height. Okay, if position of the meta center is above center of gravity, is above center of gravity, it has nothing to do with center of buoyancy. So that's why this will not be the right answer. Option D will be correct. Okay, rest all these statements are correct, that for cargo ships the metacentric height will vary with the loading, and for this position of the meta center will be different for different condition depending on the axis of rotation. Again, a beautiful question. A spherical balloon of 1.5 meter diameter is completely immersed in the water and it is chained to the bottom. So we are having a balloon which is obviously of a spherical shape, and this balloon is basically chained to the bottom. Okay, it is chained to the bottom, it is fixed to the bottom, and I think we have solved this kind of similar question earlier. This is a spherical balloon, obviously Okay. The diameter of this balloon is 1.5 meter. You have to find the weight of the balloon will be nearly. What will the weight of the balloon? Obviously, this balloon will be having different kind of forces acting on the balloon. Firstly, because this string or this chain, with the help of which this balloon is tied to the bottom, on this string there will be tension force acting. Tension force will be acting away from the body, okay, and buoyancy force will be acting in the upward direction, and weight of the body will be acting in the downward direction. You have to find the weight of the body. So weight of the body plus tension is equal to buoyancy force. So weight will be equal to buoyant force minus tension force. Okay. If you somehow get the value of buoyant force will be equal to density of the fluid into G into volume of the displaced fluid minus surface tension, which is 10. Solve this and you will get the answer. Clear? Understood the question? Try to solve it, everyone. Tell me the right answer. 7.33. Some of you are getting 7.33. Neeraj, Renault. I guess most of you have already solved these questions. These are all important engineering services previous year questions. And maybe these questions are not repeated in the future, but you need to remember the concept. Direction of the forces, how direction of the forces will act. So you will get density is 1000 into 9.81. How will you find the volume? Volume will be 4 by 3 pi r. This is r. R is 1.5. Radius is 1.5. Sorry, radius will be 0.75. No? 0.75 cube minus 10. Solve it, you will get 7.33 kilonewton. Okay. Option D will be the right answer. Next question. A two-dimensional flow field has velocity components along x and y axis given by u is equal to x square t and v is equal to minus 2x yt. T is the time. The equation of the streamline for the given velocity field is equation of the streamline for two-dimensional flow. For a two-dimensional flow, equation of streamline is, what is the equation of streamline for two-dimensional flow? It is dx by u is equal to dy by v. This is the equation of streamline for two-dimensional flow. Here u and v component of the velocity are given with respect to time. Just put the values. Dx by u is x square t and this is minus 2x yt. T will get cancelled out. This x will get cancelled out. You will get dx by x is equal to dy by minus 2y. Solve it and tell me what will be the right answer. Yes, everyone. Just integration. You have to do small integration and you will get the answer. You have to do a small integration here and you will get your right answer. So when you integrate both sides, you will get log x is equal to minus half log y plus log c. Log c is a constant, you know that, okay, or simply you can say c. If you multiply both sides 2, you will get 2 log x is equal to minus log y plus c. You can take constant as c only, okay, or you can say this is log x square plus log y is equal to c. If you take this side, you will get x square into y is equal to constant. X square into y is equal to constant will be the equation. Okay. So the right answer will be option B for this question. X square into y is equal to constant. Next question. In a steady flow along a streamline at a location in the flow, velocity head is 6 meter, pressure head is 3 meter and potential head is 4 meter. the height of hydraulic gradient line at this location will be. You have to find the height of hydraulic gradient line. Hydraulic gradient line is equal to sum of pressure head plus potential head. Pressure head here is 3 meter, potential head is 4 meter, you will get this as 7 meter. If you have to find the height of thermal total energy line, this will be pressure head plus potential head plus kinetic head. Just sum of all these will give you 13 meter. 13 meter will be give you the height of total energy line, and 7 meter is the height of hydraulic gradient line. Okay, so the right answer will be option D, because you have to find the height of hydraulic gradient line. Consider the following statements. A streamline and path line are instantaneous line. Instantaneous means which are function of time. Okay, obviously they are function of time, and you get this at a particular instant of time you capture the flow of these flow of the fluid. Okay, streamline, path line are different flow patterns. Path lines and streak lines are generated by passage of time. Path line can be found by time exposure of a marked particle. A streamline, path line and streak lines are identical in the steady flow. So there are basically 4 statements about different types of line. You have to tell which of the following statements are correct. All these are basically 3 types of flow pattern. When a fluid will flow, it will follow different types of pattern. One is basically streamline, one is path line, one is streak line. Which of the following statement will be correct about this? So here you must be thinking all the statements are absolutely correct. All these statements are correct, but in this question you need to understand the first statement, streamline and path line are instantaneous line. Both are not instantaneous line. Streamline and path line both are not instantaneous line. Path line is instantaneous line, it is generated by passage of the time, but streamline are imaginary lines. These are imaginary lines in the fluid flow, such that if you draw a tangent to any point on the streamline, it will give you velocity in that particular direction. So here streamline and path line are not both instantaneous line. Okay, they both are not instantaneous line. Path lines are instantaneous, streamlines are. So there is a confusion over this. Most of you are marking option D as the answer. And tell me, do you think that path line, streak line both are instantaneous line? Is streamline also instantaneous line? These are imaginary lines in the fluid flow. These are imaginary lines in fluid flow drawn at any instant of time. Okay, so is this also instantaneous line like other lines? Yeah, so if this is engineering services previous year question, streamline are considered to be instantaneous, but they are not actually instantaneous line. They are drawn at a given instant of time. Okay, these are imaginary line which gives you the velocity of direction vector, but they are drawn in instant of time. They are not instantaneous line. So the right answer will be option B for this question. A streamline are not considered to be not instantaneous line. Okay, path line are, but streamline are not instantaneous line. Next question. Guys, just wait for a few minutes. I will be those who are leaving the session, I must tell you that there are some good questions coming in the slides, upcoming slides. Okay, I will be taking 15 more minutes. I know today is Sunday and you all want to enjoy your Sunday and you want to have fun, but I want to tell you that these questions are important. See all these questions from all the topics, including hydraulic turbines, I have taken for today's session. When a liquid is poured into a different shaped vessel with base area same and equal height, the apparent contradiction of the equal force at the base but different weight of the liquid is called hydrostatic paradox. Understood? So basically you must have seen this kind of example where hydrostatic paradox itself says that if there are different shaped containers and you want to measure pressure at the same point, right, for different shaped container, but the weight can be different for those containers, but the pressure will be same at that particular point. That is called hydrostatic paradox. And Bernoulli equation is valid for in-viscid fluid. This is also correct. But these two are not related to each other. Both the statements are individually true. They are individual. This is also true about hydrostatic paradox, and this is also true. Bernoulli equation is valid for in-viscid fluid. But this is not the explanation for statement number 1. Statement 2 is not the explanation for statement 1. So right answer will be B. A liquid flows downward at the tapered vertical portion of a pipe. At the entrance and exit of the pipe, the static pressure are equal. If for a vertical height h, the velocity becomes 4 times, then ratio of h to the velocity head at the entrance will be. So we are having a tapered section of a pipe like this. We are having a tapered pipe. So there are two sections of the pipe. Let's say this is section number 1, this is section number 2. Okay. And liquid is flowing through this vertical tapered portion of a pipe. At the entrance and exit, the pressure are equal. So whatever is the pressure here, the same pressure will be at point number 2. So P1 is equal to P2. Let us say this height is equal to h, already given. This is h height. Okay. You have to find the ratio of the height h to the velocity head at the entrance. Velocity head at the entrance will be v1 square by 2g. You have to find this value. What will be this value? Understood the question, everyone? So how you will find, how you will solve this question? Bernoulli equation. Let's apply the Bernoulli equation. Bernoulli's equation between 1 and section 2. It will be P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2. Now, this will be 0 because pressure at both the section is same, and Z2 will be 0 because we are already taking Z as reference, point number 2 as reference, so this will be 0. Okay? Is it clear to everyone? Now, anything given about the velocity? Yes, velocity becomes 4 times. That is, velocity at section 2 is equal to 4 times at section 1. Okay, so this is V1 square by 2g. Z1 is h is equal to, this is 16 V1 square by 2g. Okay, because V2 is 4 times V1. Right? So when you solve this, you will obviously, this will be 15. Just solve this equation. If you solve this equation, you will get h by v1 square by 2g is equal to 15. So the right answer is option C. Clear? Is it clear to everyone? Next question. A pipe having a length of 200 meter and 200 mm diameter with friction factor of 0.015 is to be replaced by a 400 mm diameter pipe of friction factor 0.012 to convey the same quantity of flow. The equivalent length of the new pipe for the same head loss will be. What is the formula for the head loss? Head loss is equal to FLQ square by 12 d power 5. This is one formula for the head loss, and here we'll be using this formula. Head loss in the first pipe is equal to head loss in the second. So this will be F1 L1 Q1 square is by 12 d1 power 5 is equal to F2 L2 q2 square by 12 d2 power 5. This will get cancelled out. Discharge is same given the question. Okay, you have to find the equivalent length. This you have to find. Everything else is given, right? Friction factor initially is 0.015 into L1. L1 is 200 meter divided by D1 is 0.2 power 5 is equal to F2 is 0.012 into L2 by, this is 400 mm, this is 0.4 power 5. Solve it. Manoj Prabhakaran, you want marathon classes on Saturday, Sunday? I have to ask my team for that. Okay, I have to ask my team for the marathon session, and if they allow us, definitely I will take the marathon session, because marathon session is basically it will be at least of 2 to 3 hours minimum. Then only it will be called marathon session, and for that I need to ask my team that if marathon session is allowed or not, because generally we can take marathon session if it's exam time or we are having any upcoming exam, then definitely we can take marathon session. The transition Reynolds number for a flow over a flat plate is given. What is the meaning of transition Reynolds number? Transition Reynolds number means it will decide whether the flow will go from laminar to turbulent. Okay, flow will go from laminar to turbulent. This is decided based on a Reynolds number. For a flat plate, that value is 5 10 power 5. If the value will cross this value, see, if the Reynolds number will cross this, it will be 4 into F or F. See, doesn't matter even if I take 4 into F, because here it is friction factor. First of all, here it is friction factor. If it is friction factor, it will be F, and F is equal to 4 times F dash. Okay, this is friction factor. If it is not friction factor, अगर friction coefficient भी लेते हैं तो वो 4 cancel हो जाता. Okay, this is coefficient of friction. So if coefficient of friction would have been given in the question, then you would have used 4. But here they have given the value of friction factor. That's why we have used this formula. Clear? Now in this question they have given the kinematic viscosity. Reynolds number is equal to V into D by nu. This is formula we'll be using here. What is the distance from the leading edge? So here will not be using D. Here we have to use X. What is the distance from the leading edge? We are having a flat plate, and on that flat plate, this is the leading edge. Okay, obviously on this flat plate the flow will go from laminar to turbulent. Okay, so they are asking this question, what is the distance from the leading edge at which the transition will occur from laminar to turbulent? Okay, so you have to find this value of X. So X will be equal to Reynolds number into nu by V. So Reynolds number is given already. This is also given. Kinematic viscosity and velocity is given as 1. Just put all the values, you will get the answer. You will get 0.43 meter. Are you all getting this value? Next, at what distance, which is R, from the center of the pipe of radius R, does average velocity occur in the laminar flow? Understood the question? So we are having a pipe, obviously we are having a pipe here, and the radius of the pipe is given as, the radius is R. At the center of the pipe, the velocity will be maximum velocity, obviously. So you know that there is a formula of local velocity. Local velocity is equal to minus 1 by 4 mu del P by del X R square 1 minus R square by R square. This is a formula. In this formula, this is the maximum velocity. Maximum velocity is equal to minus 1 by 4 mu del P by del X R square. So if this is the maximum velocity, you know that for laminar flow through pipe, the average velocity is equal to half of maximum velocity. Okay, so average velocity will be minus 1 by 8 mu del p by del x of r square. Tell me, is it correct or not? What is the question in this session? The question asked here is, at what distance, what will be the value of r from center of the pipe of radius r does average velocity occur in the laminar flow? That means if this local velocity becomes equal to average velocity, if u becomes equal to average velocity, then what will be equal to what will be r? So just equate this. U is minus 1 by 8 mu del p by del x r square, and that is equal to minus 1 by 4 mu del p by del x r square 1 minus r square by r square. This will get cancelled out, right? You will get 2 here, and you solve it, you will get r is equal to 0.707 of r. Okay, most of you already know the answer. That's why you have directly some of you have written 0.707 r, but this is a concept for this question. An oil of viscosity 8 poise flows between two parallel fixed plates which are kept at a distance of 30 mm apart. If the drop of pressure for a length of 1 meter is 0.3 into 10 power 4 Newton per meter square and the width of the plate is 500 mm, the rate of oil flow between the two plates will be. So we are having two parallel fixed plates. This question came in engineering services exam. This is a previous year question of engineering services. Okay, we are having two parallel fixed plate and the distance between these two plates is 30 mm apart. If the drop of the pressure for a length of 1 meter, that is pressure drop, you know that for flow between two parallel fixed plate, what is the pressure drop? What is the formula for pressure drop for flow between two parallel fixed plate? You know the formula? Yes? Do you know the formula for this? Pressure drop between two parallel fixed plate. For pipe it is 32 mu L by d square, right? For flat plate this is okay, just a second. Okay, no problem. Let's solve it. This is 12 mu v L by b square. Let us say this distance is b. This is 30 meters. So this is the formula. Remember the formula, something like this. L is 1 meter. So this is delta p by L. Let us say this is 1 meter. This is given as 0.3 10 power 4. So delta p by L will be equal to delta p by L, which is equal to 12 mu into v by b square. Okay, what you have to find this question? From this you can find the value of if you somehow get the value of velocity, you can get the value of discharge. Discharge will be equal to area into velocity. Okay, simple. Yes, tell me. Viscosity is given as 8 poise. So you can solve this and tell me the value of velocity from here. So this is 0.3 in 10 power 4 is equal to 12 into 0.8 into V by 0.03 square. From here you will get value of V. Width of the plate is given. Okay. So area you can find from here. Area will be equal to width into the distance between the plate is thickness is 30. So you can find the value of area and multiply area with velocity and you will get the answer. Tell me. Understood the question, everyone? I try to solve it. Yeah. Use your calculator, try to solve it and tell me the answer. The formula is correct. Everything is correct. You will get the velocity, which is 0.281. Solve it, you will get the velocity as 0.281 meter per second. Okay. Are you all getting this velocity by solving it? And what is area? Area will be equal to width. Width is 500 mm, which is 0.5 meter into 30 mm. This is so this will be 0.03 into velocity 0.281. Solve it, you will get the answer of discharge 4.22 10 power minus 3 meter cube per second. Okay, simple. Are you all getting this value, everyone? Tell me. Are you getting this value? Next question. For rough pipe having turbulent flow, the friction factor is a function of. See, friction factor for laminar flow, you know that for laminar flow in pipe, friction factor is a function of Reynolds number. Okay, friction factor is a function of Reynolds number for laminar flow. But for turbulent flow in pipe, friction factor is not just a function of the Reynolds number. Friction factor is a function of Reynolds number and roughness or relative roughness of the pipe surface, right? The right answer is option A in this case. It's not just a function of this, but it is a function of Reynolds number and the relative roughness. Consider the following types of turbine: Francis turbine, Pelton wheel turbine with 2 or more jets, Pelton wheel with single jets, Kaplan. These are different types of turbine. The correct sequence of these turbine in the increasing order of their specific speed. You know that specific speed is a parameter which is a formula which is n square root of p. Here the p is the shaft power. Okay. This has to be kept in kilowatt. Always remember when you have to solve the question. There is one more formula for a specific speed, that is n square root of n into p h power 5 by 4. Here small n stands for number of jet. And there is one more formula for a specific speed, which is n root n into p divided by g into h or 5 by 4. This is also called as dimensionless form of specific speed. Dimensionless form of specific speed, right? In this case, increasing order of specific speed will be Pelton wheel with single jet will be having the least specific speed and highest will be for Kaplan. So 3 will be the lowest and 4 will be the highest. After 3 it will be 2. So 3, 2, 1, 4. Option B is the right answer. Okay. A single jet impulse turbine of 10 megawatt capacity works with a head of 500 meter. If the specific speed of turbine is 10, the actual speed of turbine is specific speed is equal to n root p h power by this is the formula, you know that I have just written this formula. If specific speed is given as 10, you have to find the actual speed. Here you have to keep the power, but that power has to be in kilowatt. So this is 10 megawatt. This has to be 10,000 kilowatt. So 10,000 kilowatt. Head is 500 meter. 500 power 5 by 4. Solve it, you will get the value of n. Yes. What will be the value of n? So you will get 236.4 RPM. Okay. Next question. A turbine is to operate under a head of 30 meter while running at 120 RPM using 12 meter cube per second discharge at 90% efficiency. Which of the following turbine types would suit the condition? H पावर 3/4 कहाँ पे होता है? अरुणाचल एंटरटेनमेंट. आई थिंक आप अपने कंसेप्ट को थोड़ा सा रिवाइज करिए. दिस इज अ वेरी सिंपल फॉर्मूला. अरुणाचल एंटरटेनमेंट. ऐसी भी क्या मजबूरी आ गई कि आपको अपना नाम ऐसा रखना पड़ रहा है ना? आप अपना ओरिजिनल नाम से भी आ सकते हैं यूट्यूब में. इट डज नॉट लुक गुड ना एवरी टाइम आई हैव टू कॉल. सी देयर आर अदर स्टूडेंट्स आल्सो हु आर हैविंग देयर नेम एज MS Ramjeevan, and MS is also fine, but you could have named yourself as AE at least. ये ज़्यादा बेटर लगता. अरुणाचल एंटरटेनमेंट कैसा लग रहा है? मैं किसी नाम को नहीं कर रहा हूँ, बट ये आपका ओरिजिनल नेम तो नहीं है, राइट? So how to solve this question? First of all, how you classify, how you tell which of the turbine, which of the following will be the type of turbine? Depending on the specific speed. Specific speed is equal to n root p h power by 5/4. Yeah, basically he is recalling the formula for a specific speed of pump, which is n root q h power 3/4. So that's why he is having confusion. Okay, so that is not the formula. Arunachal Entertainment. For turbine this will be 5/4. For pump it will be 3/4. And in the case of pump, it will be square root of discharge, not power. So you are getting confused between the two formulas. First of all, in order to solve this equation, you have everything here, but you don't have the value of the power, shaft power. So you have the specific speed. Sorry, you have the speed. You have the head, which is 30. But you don't have the power. How to find the power? You know that overall efficiency is equal to shaft power divided by water power, which is rho GQH by 1000. These two will get cancelled out. Shaft power you have to find here. Shaft power will be the power which is to be put over here. This will be overall efficiency is 0.9 into G is 9.81. into Q is 12 into H is 30. Get the value of shaft power in kilowatt, put it here and get the value of specific speed. Based on the specific speed, you can classify the type of turbine. Okay, tell me the answer, everyone. This is also the last question, second last question. After this, I will take this one more question and that's all for today. I think I have tried to cover the question from all the topics of fluid mechanics. So you will get power as 3178.44. Just put the value here, you will get a specific speed from here. So you will get the value of specific speed, which will be somewhat. What is the specific speed you are getting for this question? Tell me. What is the specific speed you are getting for this question, this particular question? Based on the specific speed, you can classify the turbine. Okay. So 96.35 will be the specific speed, 96.35 RPM. Now 96 are based on this, it will be Francis turbine, because Francis turbine have a specific speed in the range of 50 to 250 RPM. Okay, that will be Francis. The last question is, I think you can easily solve it. The power is given, head is given, discharge is given, find the overall efficiency. Overall efficiency will be shaft power divided by water power, which is rho GQH by 1000. This will get cancelled out. It will be shaft power, which is 3000. G is 9.81. Q is 75. H is 5. Solve it. Tell me the answer. What is the efficiency? Last question for today's session. Just remember these formula. If you don't remember the formula, or you just get confused with the formula, see, don't remember the formula, that's fine, you can leave the question. But if you get confused in the formula, it will be a mistake. So you will get 81.5%, approximately 82%. Okay, so that's all for today. I hope you have enjoyed today's session, all the questions. Only thing that was left was, I think, there were few topics which were left. Rest of the question will take in some other session. Till then, take care. Have a nice day. Tomorrow, I will not see you tomorrow. It depends. Maybe I will take the session tomorrow, or maybe not. If I will take the session tomorrow, you will get to know. Okay. So that's all, my dear students. Thank you so much. If you have enjoyed today's session, you can just reply me in the comment box if you have liked today's session. And that's all. The session was supposed to be for 60 minutes. I think I have taken much more time. Okay. The allotted time is 60 minutes. So I think I have already taken a lot of time. So thank you so much for joining me for this session. Have a nice day. And I will definitely take formula revision classes. Don't worry. We'll take these kind of classes also. I will schedule these kind of classes, formula revision classes and marathon classes. I know you have so many things that you want from us, but one by one we'll definitely cover all the things. These were the few practice questions on fluid mechanics, and as soon as the exam will come, we'll take the formula revision classes, marathon classes also. Don't worry. Okay. We also want to give you the best thing, so that जो भी लोग एग्जाम की तैयारी कर रहे हैं, those who are preparing for some exams like SSC JE CBT2 or RRB JEs, so we can provide you the best session. Okay, so we also know that कि हमें क्या provide करना है आप लोगों को. Don't worry about it. Just follow this session and subscribe to our channel. Thank you so much. Have a nice day. Thank you.